This lesson is going to be on significant figures and more particularly how are calculations made with significant figures. There are going to be two rules, one for multiplication and division, one for addition and subtraction. The rule for multiplication and division is your answer cannot have more significant figures than the measurement with the least number of significant figures. So if this particular measurement has 4 significant figures, this one has 2 significant figures, your answer can only have 2 significant figures since that is the number with the lower number of significant figures. So by multiplication and division, you always go by the total number of significant figures. The number with the least total number of significant figures is what your answer can have. So if I get my calculator out, multiply 5 times 1, I'm going to see the number 5. The number 5 only has one significant figure, and so I need to make that 5.0 because now I have two significant figures matching my number with the least number of significant figures. If I have a number that has 3 significant figures and want to divide it by a number that has 2 significant figures, then my answer can only have 2 significant figures. In this case, when I divide those two numbers, I get 2,500, which is fine because that only has 2 significant figures. Again, trailing zeros are not significant unless they are to the right of both a decimal and a non-zero digit. I could change it to scientific notation and make it 2.5 times 10 to the third, but that would not be necessary, but that is an option since both of those have 2 significant figures. This number has 2 significant figures. This number has 4 significant figures, so my answer then can only have 2 significant figures. 5 times 100 is going to be 500. The number written that way, though, only has one significant figure, the 5. The trailing zeros are not significant. Here's a case where we want to make a trailing zero significant. We want to make that first zero significant. And to do that, we change it to scientific notation. So if I change it to 5.0 times 10 to the second, I have the same magnitude that equals 500. But now I'm showing the second zero as being significant because now it is to the right of a decimal and to the right of a non-zero digit, or now my answer has 2 significant figures. Next one, if I take a number with 3 significant figures and I multiply it by a number with 2 significant figures, I'm going to require, or I'll be required to answer my number in 2 significant figures. That comes out to 6.87, which has 3 significant figures, and so I need to round this. Do not just chop off. You want to round it to the correct number of significant figures. Now it has 2 significant figures. So again, multiplication and division, your answer can have no more sig figs than the number with the least number of significant figures. Since we had to round this, let's practice rounding a little bit. If we have this particular number, 8,995, and I want to round that to 3 significant figures, I need to round to the third significant figure, that 9. The 5 is going to make that round up to 10, and that's going to make that round up to 9,000. 9,000 only has one significant figure. And so again, we want to change this to get 3 significant figures. I want to make a trailing zero significant. So again, we need to change that to scientific notation. If I want to round 877,000 to 2 significant figures, I need to round to this place. Again, I'm not going to go 88. That is not even near the correct number. You need all those zeros at the end as place holders, and so 880,000 is correct. I could do 8.8 times 10 to the 5th. That would also be correct. Both of those have 2 significant figures. And on this next one, if I want to round this to 3 significant figures, I want to round to this place. Do not overthink and think, well, if this is a 9, I need to round that to a 5 and round that up. No, you only look at the next digit in line. If I want to round to this place, I only look at this place. Since 4 is less than 5, I'm going to round down. So that comes out to 566,000. For addition and subtraction, now we don't care about the total number of significant figures. Now all we care about is the number of decimal places. Your answer can have no more decimal places than the measurement with the least number of decimal places. So if I have a number with 3 decimal places and one with 1 decimal place, then my answer must have only 1 decimal place. So that is going to be 5.0. If I wasn't thinking too correctly and I wanted to subtract these two numbers and I said this one has 4 sig figs, this one has 7 sig figs, therefore my answer must have 4 sig figs, I would be wrong. Again, addition, subtraction, we don't care about the total number of sig figs, we only care about the number of decimal places. This one has 1, this one has more than 1, so my answer can only have 1 decimal place. 99.5 would be the correct answer. And the last one here, this one has 2 decimal places. This one has 3 decimal places. So my answer can only have 2 decimal places. And so on the calculator, I'll get 2.555. Again, don't just chop off. You need to round off. So it's not 2.55, but 2.56.